Last, I want to run through a few more examples before we summarize. And so the first two are just going to be finding components. And again, the important thing to remember here is that you need to find this length. So don't just say that b sub x is equal to -1. It's not. If you notice, b sub x is equal to -2, and don't forget your units, meters. And we get that by looking at this difference here. Similarly, when we come up to b sub y, we again want to look at this length here, and we get that b sub y is equal to +2 meters. And so even though my b vector ends at this point, it began over here at +1 in x and +1 in y. So remember that it's going to be clearest usually to work with your vectors if you actually take your vector and have it start at the origin. Now it clearly is pointing to -2 in x, -2 in y. So please be careful about that. And again, in this case, make sure that you've gotten your signs right. One more of these examples, something I want to highlight here is that, some tick marks are missing. That's not too bad, that clearly the value between 1 and 3 is 2. The value between 0 and -1 is -1. And so again, we see that we're not started at the origin, so one way to deal with that is to recopy your vector and actually move it to the origin. But obviously that's going to be a little tricky to do on your own paper, and in this case it looks like it's come all the way down to -3. And when we look at what the length is, we do in fact get -3 in the y. And here we're going from 1 to 4, 1 to 3. So here actually we have that +4. So if I wanted to write this vector, I could say that my vector is +4 meters in the x hat direction plus -3 meters in the y hat direction. Another way that you could write this, which would be fine, would be to actually keep very explicitly your magnitude out front and then your direction. And so here this would be 3 meters in magnitude in the -y hat direction. Sometimes I write it that way to just really remember that it's pointing in the negative direction, but it has a magnitude of 3 meters. So again, perfectly equivalent. So now I want to do an example that's again relating those component vectors to angles. And one thing here to note is we are now not in the first quadrant, so we have to be a little more careful about our minus signs. So if I wanted to create my by vector, we see that that is going in the -y direction. Now you can either create your bx vector up here, that's fine, or I might choose to create it down here on that side of the triangle, and that's again the exact same vector if I've done a good job drawing them. So now again, notice that you have a right triangle and that the x side is here, the y side is here. Your angle is now this one. There's nothing wrong with that. You just have to keep track of which angle you're working with, since this is now your opposite side and this is now your adjacent side. So be careful about always following some sort of recipe where y is always opposite, because it's not. It just depends on what angle you have. So this is a case where we've defined your angle phi to be this upper angle. Nothing wrong with that. So please be careful about that. And again, in this case, if for instance I knew my magnitude and my angle, I could say that, for instance, by is equal to, right, because by was adjacent, so that's going to be b cosine of phi. I've done a terrible job drawing this phi, sorry. Now be careful, because we also see that by must be negative. So when I write it this way, I'm only thinking about the magnitude. And this is one place where you might be careful, because the book might do it a little bit different than me. I would say that my by vector is equal to, in this case, b cos phi in my negative y hat direction. So this is one reason why I always keep my pluses and minuses with the direction, is that when you go to do this, you don't get a minus sign out. You're going to get a positive value. But we see that by itself is in the negative direction. So you can either explicitly put it here, or you can put it here, but don't do both. It's one or it's the other. So in this case, I typically just put it explicitly with the direction. So to summarize, make sure that you're defining your coordinate system very clearly. That's going to almost always mean drawing it. And frequently we're going to be working in x, y, though I encourage you to use parallel and perpendicular if you're working with a tilted coordinate system. Make sure that you have a clearly defined origin and directions. What's positive, what's negative, what's x, and what's y. Use your unit vectors, which again really capture what the direction is, or you can use component vectors, for instance that a sub x, which really has the unit vector in it when we are quantitatively describing vectors. And the next video is going to get into adding and subtracting vectors, and so you'll actually see how all of those quantitative pieces are needed. Finally, we are going to be using trig to really convert between those polar forms, meaning magnitude and direction, and these coordinate forms. Whenever you're adding or subtracting vectors, you really need the coordinate form and not the magnitude form, but you might know initially the magnitude form, or you might need to give your answer in the magnitude form. So you have to use trig to do that, and again, if you're not comfortable with trig, please watch that review video.